This is problem 40 from the Math Level 2 practice exam, the solution. You have a function that is q of x equals the opposite of x plus 2 times x minus 2 times x minus 3. And we need to find out which statements are true about q of x. And the first statement is q of x equals 0 has 0 solutions. Well, if we want to make that function equal to 0, what we're saying is and this actually has 3 real solutions. You have -2, 2, and 3. So that means that 1 is false. Roman numeral 1. That's false. Now we go here to item 2, which is as x approaches negative infinity, the function approaches negative infinity. So this is a cubic. We looked at those roots, so a quick sketch might serve us well. We have root at -2, 2, and 3. When x equals 0, you have 2 times -2 is -4, times -3 is +12, times another negative, that's going to be -12. So somewhere here, it's not drawn to scale or anything. And you end up with, all these are multiplicity 1, so the function carries through those. And you get something like this. That may or may not be the local minimum. But the point is that you can kind of draw the end behavior. So what is happening here? It says as x approaches negative infinity, which this of course is the x-axis, the function itself gets greater, which means that it doesn't approach negative infinity, which means that 2 is false, Roman numeral 2. Now we'll try and get this last one in here. Okay, and this one states, well, q of x less than or equal to 0 for -2 less than x less than 0. So we're looking kind of a little bit more closely. Might be able to fit this one right on our paper here. Keep in mind we had -2 as a root, and it dropped down here to -8 for an intercept. I'm sorry, it was -12. And the polynomial looked something like this. But the part that we care about is this part right here. When x is less than or equal to 0 and greater than or equal to -2. So is the function less than or equal to 0 over that interval? And yes, it's true. It's equal to 0 when x equals -2, and after that it's always going to be negative. So we know that Roman numeral 3 is actually true. So on this particular problem, Roman numerals 1 and 2 are both false. The only true one is 3, which is choice C.